so this week we're going to take a look at Pythagorean theorem, which looks like it lines up with what some of you are doing in geometry anyway. Can anybody tell me what's the formula for Pythagorean theorem? Yeah?
A squared plus b squared equals c squared.
Yeah, a squared plus b squared equals c squared. Just make sure we know what the a, the b, and the c are. Okay. The a and the b are the two short sides of the triangle. We call those the legs. And c is the long side. We always call that the hypotenuse. So there's a picture of a triangle with the two short sides labeled as A and B, and the long side, which is always across from the 90, is your hypotenuse at C. So that's the formula, and let's just look at an example. So let's see if we can find C. Can someone remind me again, what's the formula we use to find C? Yeah? And you don't have to give me any numbers, just give me letters.
The A
Yep.
and B.
A squared
A squared and plus B squared
plus B squared
equals C squared.
equals C squared. Okay. Now, I see C on the triangle. I don't see where A and B are. Which one of these numbers could be A? Yeah. go
The
ahead.
18.
Yep, the 18, that one could be A, sure. So if that one's A, Micah, which one is B?
80.
Yep, that's going to be the B. So now we just have to plug them in and see what we get. Colin, what are we going to plug in for A?
Whatever 18 times 18 is.
Yeah, we'll figure that out. But for A, we're just going to plug in 18. Sorry, A is 18. Miriam, what are we going to plug in for B? Yeah, 80. And what about for C? Do we plug in anything for that? Nathan? No, because that's the letter. You always have to have one letter. That's the letter we don't know. All right, so now we need our calculator. Let's do 18 times 18 gives us 324. And then 80 times 80 gives us 6,400. And what do I have to do with the 324 and the 6,400? Yep. Yep, I'm going to add them up. So that's going to give me 6724. Now that's not C, that's C squared. So anybody know the very last thing you have to do to get rid of this exponent of 2? Yep.
Square root.
Yep, exactly. Take the square root on both sides. And whatever the square root of 6,724 is, that is your answer. 6,724 is 82. And that's it. That's how you do the Pythagorean theorem. So C is 82. And we should put a label on it. What should it be? 82 what?
82 squared.
82 what?
Squared.
Kilometers, because they had kilometers on here. So they're measuring distance, 82 kilometers. All right. Example 2 is pretty similar, so I want to try example 3 and 4 because those are a little harder. What's different about example 3 and 4 than example 1 and 2? Yep.
They're word problems.
Yeah, they're word problems. So the first thing you want to do is, if they give you a word problem, draw a picture, and somewhere in your picture is going to be a triangle. So this one says that a squirrel lives in a nest 12 meters high in a tree. They want to reach an acorn that is rolled 5 meters away from the base of the tree. How far will the squirrel have to glide to the ground? All right. So what's well, one thing that's important in this picture is the ground. So let's put the ground. Can somebody tell me something else that's important to put in the picture? Yeah.
Tree.
Yeah, so we've got a tree. So let's just put, we'll just put a tree over here. So we got a tree. And it says that the squirrel lives in a nest in the tree that is how high off the ground? Yeah,
12 meters.
12 meters. So let's say the squirrel nest is right there in the tree. It's 12 meters from that nest all the way straight to the ground. So that's 12 meters. Now it says that there's an acorn on the ground, and how far is the acorn from the tree? How far does it say the acorn is from the tree? Yeah.
5 meters.
5 meters. Let's put the acorn right over here. There's the acorn. And that acorn is 5 meters away from the tree. So the squirrel is going to, flying squirrel, is going to glide straight down like that to get to the acorn. It's going to glide straight down. The question is, how far does the squirrel have to glide? Okay. What's the formula we need to use to figure that out? Yep.
A to
A squared.
A squared plus B squared
Yep.
equals C squared.
Equals C squared. Okay. Joe Smiley, what's A in this case? Sorry, what number is it? Yep, so that could be the 12. So 12 squared. Caleb, what's B in this case?
B.
Yeah. So think back to your Pythagorean theorem. What do the A and the B represent in your theorem?
5.
5, yep. And what about the C?
17.
How do we know that?
Because you have the two together. There's a plus.
Well, we got to look at our picture. Where's C in our picture?
Corner.
Well, it's one of the sides. Can anybody tell what triangle, what part of the triangle is it?
The dotted line.
It's the dotted line. And the question is, how far does the squirrel have to glide to the ground? So do we know C? Just that? No, that's the whole question. How far does the squirrel have to glide to the ground? All right, so now we just have to figure out what C is. Kara, what do I have to do first there?
Multiply them by itself.
Yep, so 12 times 12. Anybody tell me what's 12 times 12? Yep. 144, good. How about 5 times 5? 25. And now we got to add them up. What do you get if you add 144 plus 25? 169. And what's the last thing we have to do?
Divided by 2.
We got to, careful, it's not this. If it was that, we'd divide by 2.
Square root.
We have to take the square root. Yep. So take the square root. Take the square root. And if it doesn't come out nice, we'll just round it. If it comes out nice, then that's great. So we get 13. And what should we put for a label on that?
Meters.
Meters. Yeah, so just use whatever unit they use in the original problem. So how far does the squirrel have to glide from the tree to the ground if they glide straight towards the acorn? 13 meters. Yep. Okay. And the last one. So It says Wyatt takes a rectangular piece of fabric and he makes a diagonal cut corner to corner. The cut that they make is 17 centimeters long and the fabric has a width of 15 centimeters. All right. So let's start with what is the shape of the piece of fabric? Rectangle. Yep. So let's start with that. That's a square. Let's try a rectangle. Perfect. How does Wyatt cut the rectangle? Yep.
Diagonal.
Cuts it diagonal. So he's going to make a cut just like this. How long of a cut does he make diagonally? Yeah?
17 centimeters.
17 centimeters. Perfect. Now, what other piece of information do they tell us about the fabric? Tell me one other thing. Yeah?
It is 15 centimeters wide.
Right. It's 15 centimeters wide. So now we're looking at this triangle right there. That triangle in blue. The 17 is also called the what of the triangle?
Hypotenuse.
Yep. And 15 is one of the legs. And the question is, what is the length? Well, I think I put it in the wrong spot, but the question is just to solve for x. Or whatever letter you want to use. I won't assume we want to use x. What letter do you guys want to use for that third side?
Should just be.
Yeah, because you only have 7 minutes. Yeah.
Is it A?
Yeah, we could use A. A lot of times I use X. That doesn't matter. Whatever letter you want to use. And can someone set up the Pythagorean theorem for me using the 15, the A, and the 17? So what am I going to fill in?
15 plus 17.
So 15 squared plus
17 squared.
So this, what do we call this side again in the triangle? That's one of my, what's the word they use for that? That's one of my legs. How about this one? This is one of my legs. And what about this one? Hypotenuse. So I agree, 15 is one of the legs. Is the other leg 17?
No.
What's the other leg?
A.
A. So we're going to put A there. And then what's the hypotenuse? Yeah, 17. Good. So you might not always end up with all the numbers on one side. You might have some numbers on the left, some numbers on the right. Okay. What do I have to do now on the left-hand side?
Multiply 15 by itself.
Yep, and I just tell you what that is. That's 225. A, we don't have a number for, so we just have to leave it. And what do I have to do on the right-hand side?
You have to multiply by 17.
Perfect. 17 times 17, which gives me 289. Miriam, what would be my next step to get to hopefully start to get A by itself? Yep. So minus 225. And Caleb, what does that leave me with on the left side?
What?
What does that leave me with on the left side?
A squared?
Yep, A squared. And then on the right side, 9 minus 5 gives me
4.
4. 8 minus 2,
6.
6. And 2 minus 2,
0.
it's gone. So we get A squared equals 64. And what's the last thing you got to do to get rid of that exponent of 2?
Square root.
Yep, take the square root. And does anybody know what number times itself is 64? Yep.
8.
8. Yep. And that is 8. What should we put for a label?
centimeters.
Yeah. So the length of the fabric is 8 centimeters. Perfect. Yeah, my picture is definitely not to scale because I do the width differently than the length, but that is the correct answer, 8 centimeters. Okay, so that's the kind of problems for this week. So remember, there's only 3 things: the MCAS, the 2 IXLs, and the activity on Pythagorean theorem. There are no recommended, no diagnostics. So Thursday and Friday are catch-up days this week.